Right now, 300 million light years away, something terrifying has awakened from its eternal slumber. A supermassive black hole that had been sitting quietly for millions of years has suddenly opened its eyes and begun feeding with an appetite. Unlike anything scientists have ever witnessed, this isn't science fiction. This is happening right now. And astronomers are watching it unfold in real time for the first time in human history. If you think you understand black holes, think again, because what we've discovered about SDSS 1335 plus 0728 is rewriting everything we thought we knew about. These cosmic monsters hit that subscribe button right now, because what I'm about to show you will shake your understanding of the universe. To its core, comment below if you've ever wondered what happens when a sleeping giant decides it's time to feed the galaxy. SDSS 1335 plus 0728 have been one of the most boring objects in space for over 20 years until December 2019, when everything changed forever. Astronomers have been monitoring this distant galaxy located 300 million light years from Earth, and for 2 decades it showed absolutely no signs of unusual activity. It was just another quiet galaxy among billions, containing what appeared to be a dormant supermassive black hole at its center. The black hole, estimated to be about 1 million times the mass of our sun, seemed to be in a deep cosmic sleep, showing no signs of the violent feeding behavior that characterizes active black holes. Scientists have cataloged it, studied it briefly, and then moved on to more exciting cosmic phenomena. But on a cold December night in 2019, the Zwicky Transient Facility's automated alert system detected something unprecedented. The galaxy had suddenly begun to brighten, emitting light across multiple wavelengths in a way that defied all previous observations. The brightness increase wasn't gradual or subtle. It was dramatic and sustained, like someone had suddenly switched on a cosmic lighthouse that had been dark for millions of years. The discovery sent shockwaves through the astronomical community, because witnessing the awakening of a supermassive black hole in real time had never been documented before. Dr. Paula Sanchez from the European Southern Observatory, who led the research team, described the phenomenon unprecedented behavior that challenged everything scientists thought they knew about how black holes transition from dormancy to activity. The team immediately began a comprehensive monitoring campaign using telescopes around the world and in space to track this cosmic awakening. What they discovered would revolutionize our understanding of black hole behavior and provide the first real-time glimpse into one of the universe's most violent transformations, the process of a black hole. Awakening is one of the most spectacular and violent events in the universe, comparable to watching a sleeping dragon suddenly open its eyes and unleash fire. When SDSS 1335 plus 728 central black hole began its awakening, it didn't happen gradually over millions of years as scientists had theorized. It happened with shocking speed that caught everyone off guard. The black hole's gravitational field, which had been relatively quiet, suddenly began pulling in surrounding matter with unprecedented force, creating what astronomers call an accretion disk of superheated material spiraling toward the point of no return. As matter falls toward a black hole, it accelerates to incredible speeds, reaching temperatures of millions of degrees and emitting radiation across the entire electromagnetic spectrum. The awakening process began with the black hole pulling in gas and dust from its surrounding environment, material that had been orbiting peacefully for eons, suddenly finding itself caught in an ever-tightening gravitational spiral. This material, compressed and heated to extreme temperatures, began glowing brilliantly in ultraviolet, optical, and infrared light, causing the galaxy to brighten dramatically and alerting Earth-based telescopes to the cosmic drama unfolding. The awakening wasn't just about increased brightness. It represented a fundamental change in the black hole's behavior and its relationship with its host galaxy. Scientists discovered that the black hole had transitioned from what's called a quiescent state to an active galactic nucleus, or a GN, a transformation that affects not just the immediate vicinity of the black hole, but the entire galaxy. The energy being released was so immense that it began affecting star formation rates throughout the galaxy, ionizing gas clouds thousands of light years away from the black hole itself, and creating shock waves that ripple through the galactic medium like cosmic tsunamis. What made this awakening particularly remarkable was that astronomers could compare detailed observations from before and after the event, creating the first comprehensive timeline of a black hole's transition from dormancy to activity. They found that the galaxy was now radiating significantly more light at ultraviolet, optical, and infrared wavelengths compared to observations from previous decades, providing unprecedented insight into the mechanisms that trigger such dramatic transformations in the most extreme objects in the universe. The feeding frenzy that followed the awakening of SDSS 1335 plus 0728 S black hole was unlike anything astronomers had ever witnessed, representing a cosmic banquet of destruction and energy, released that defied all previous theoretical models. In February 2024, more than 4 years after the initial awakening, the black hole began emitting X-rays for the first time, signaling that its appetite had grown even more voracious and that it was now consuming matter at rates that pushed the boundaries of what scientists thought was physically possible. These X-ray emissions weren't just any ordinary radiation. They came in the form of quasi-periodic eruptions, or QPEs, which are among the most energetic phenomena in the known universe. The X-ray bursts from SDS zone 3350728 were not only longer in duration than typical QPEs, but also significantly more luminous, challenging existing theoretical models about how black holes consume matter and convert it into energy. Each eruption released energy equivalent to billions of nuclear weapons detonating every second, creating a cosmic fireworks display visible across hundreds of millions of light years. The pattern of these eruptions suggested that the black hole was not simply consuming random material, but was likely tearing apart and devouring entire stellar objects, possibly including asteroids, comets, or even small stars that venture too close to its gravitational influence. Scientists calculated that the black hole was now feeding at a rate approximately 40 times its theoretical Eddington limit, the maximum rate at which a black hole should be able to consume matter according to classical physics. This discovery forced astronomers to reconsider fundamental assumptions about black hole physics and suggested that these cosmic monsters might be capable of growth spurts that far exceed what was previously thought possible. The implications were staggering. If black holes could feed this aggressively, it might explain how supermassive black holes grew so large so quickly in the early universe, solving a long-standing puzzle in cosmology that the feeding process created. A spectacular light show that extended far beyond the black hole itself, with jets of superheated plasma shooting out from the poles at nearly the speed of light, creating structures that stretch for thousands of light years into space. These jets, powered by the rotational energy of the black hole and the magnetic fields generated by the swirling accretion disk, acted like cosmic particle accelerators, creating some of the highest energy phenomena in the universe and potentially affecting the formation and evolution of neighboring galaxies. The discovery of this awakened black hole has profound implications for our understanding of the universe and forces scientists to reconsider many fundamental assumptions about how galaxies evolve and how supermassive black holes influence cosmic structure formation. The fact that SDSS 1335 plus 0728 could remain dormant for millions of years and then suddenly spring to life suggests that there may be countless other sleeping giants throughout the universe, waiting for the right conditions to begin their own feeding frenzies. This realization has led astronomers to estimate that we may have dramatically underestimated the number of active, supermassive black holes in the universe. The awakening also provides crucial insights into the coevolution of galaxies and their central black holes, a relationship that astronomers have long suspected but rarely been able to observe directly. The energy being released by the awakened black hole is now affecting star formation throughout its host galaxy, either triggering new star birth in some regions while completely shutting it down in others. This process, known as feedback, plays a crucial role in determining the final mass and structure of galaxies, and observing it in real time provides unprecedented data for testing theoretical models of galaxy formation and evolution. Perhaps most importantly, this discovery opens up entirely new possibilities for detecting and studying black hole awakenings in the future. Armed with new knowledge about the warning signs and timescales involved, astronomers are now developing more sophisticated monitoring systems to catch other black holes in the act of awakening. The Vera Rubin Observatory, set to begin operations soon, will survey the entire visible sky every few nights and could potentially detect dozens or even hundreds of similar events, creating a new field of time-domain black hole astronomy. The implications extend beyond pure science into questions about the safety and stability of our own galaxy. While the Milky Way's central black hole, Sagittarius A*, is currently relatively quiet, recent studies have suggested that it too experienced a period of intense activity just 200 years ago. Understanding the mechanisms that trigger black hole awakenings could help us predict whether our own galactic center might experience similar episodes in the future, and what effects such an awakening might have on life in our solar system. Study of SDE SS1335 plus 0728 has also revealed new insights into the formation of the first supermassive black holes in the early universe. By observing how quickly this black hole can consume matter and grow, scientists are beginning to understand how black holes that formed shortly after the Big Bang could have reached such enormous sizes so quickly. This addresses one of the most significant puzzles in cosmology and provides new constraints for models of early universe evolution. Looking toward the future, the awakening of SDSS 1335 plus 0728 represents just the beginning of a new era in black hole astronomy. Next-generation telescopes like the James Webb Space Telescope and the upcoming Extremely Large Telescope will be able to study such events in unprecedented detail, potentially revealing the physical mechanisms that trigger black hole awakenings, and providing new insights into the most extreme physics in the universe. These observations could lead to breakthrough discoveries about the nature of space-time itself, the behavior of matter under extreme conditions, and the fundamental laws that govern the cosmos. The discovery also highlights the importance of long-term astronomical monitoring programs and the value of maintaining detailed archives of observations. Without decades of baseline data showing SDSS 1335 plus 0728 in its dormant state, astronomers would never have been able to recognize the dramatic nature of its awakening. This underscores the critical importance of continued funding for sky survey programs and the maintenance of astronomical databases that may not show their true value until years or decades after the data is collected. As we continue to monitor SDS Zone 33-50728 and search for other awakening black holes, we are witnessing the birth of a new branch of astronomy that combines the excitement of discovering transient phenomena with the deep theoretical insights that come from studying the most extreme objects in the universe. Each new observation brings us closer to understanding not just how black holes work, but how they shape the cosmic web of galaxies and influence the evolution of the universe itself. The awakening of this cosmic monster 300 million light years away serves as a powerful reminder that the universe is far from static and that even the most seemingly stable objects can undergo dramatic transformations that challenge our understanding of physics and cosmology. As we continue to develop more sensitive instruments and more sophisticated theoretical models, we can expect many more surprises from these enigmatic objects that sit at the boundary between the known and the unknowable, where the laws of physics are pushed to their absolute limits and where the very fabric of space-time is warped beyond recognition. This discovery marks a turning point in our understanding of black holes and galaxies, opening up new questions and possibilities that will drive astronomical research for decades to come. The sleeping giants of the universe are awakening, And humanity is finally developing the tools and knowledge needed to witness and understand their incredible power.